I'm Jake Van Vleet. I was a data engineer at Data Realty downtown for the last 2 years or so. But, anyways, so today we're about meetup, I guess. So I'm a horrible public speaker, so if you guys have a question or I miss something, just try to grab my attention and ask at the time, because I'll probably forget a whole bunch of stuff. That, and I accidentally erased my slides earlier this week, so I had to make it like an hour, so forgive me on that.
There's no judgment here. It's all good.
Yeah.
You got this.
Yeah, it's a programmer group right now, a public speaking group.
We're all a bunch of awkward nerds. It's okay.
But anyways, one of the big things with big data and we've been having problems is that obviously the size of the data has been growing a lot over the last year. Just having Facebook's million users and stuff like that, and trying to keep track of it all for one thing, let alone actually get useful information out of it. All big data is just answering questions. And the hardest part, at least from my side of the thing, is trying to know what questions management wants answered. Usually if you can get the question, that's just a matter of time before you figure out how to actually answer it. But anyways, Hadoop is a really interesting. I don't know, any of you guys ever tried to parallel PCs like back in like early 2000s? Why am I always the only one that's ever tried to do that? It was a huge pain in the ass.
It's like you only look at check.
Yeah.
Everybody else already knew?
I've only got it to work like once out of like the 3 or 4 different attempts to do it. It's like I used to work on, I was in the Army for a long time, about 6 years, and then all of our systems there were like Red Hat parallel systems and stuff like that. So a couple times trying to actually replicate some of the stuff that I worked on before, it never worked out well. Because, didn't have the hardware control components. They obviously didn't really get custom board build stuff like that. But so basically Hadoop, to sum it up in the easiest way, is just an easy way to parallel computers across the network instead of trying to do specialized cables or over parallel connections. Think about it that way, it just makes a lot more sense when they talk about you have never messed with it before. And by far the best distro, it's open source. There's multiple flavors of distro Hadoop out there. Probably the bigger ones you hear about are Cloudera and Hortonworks, and they're definitely the biggest providers of or MapR, but nobody likes MapR really. It's really expensive if you want to buy the distro. But the best one, the distro that they all steal from is called Embari, which is actually open source and free to everybody. And it's the one I've used the last couple of years. It's super easy to install. I had 12 dozen clusters of it running. All the problem comes with monitoring and everything. Actually, I'll give you an idea what it looks like. This is Embari right here. You can see over here on the left, you can see an actual the rundown of the basic processes that are running on there. After the login, it's just a simple login. It gives you all like your hard drive use. This is just my little Hadoop cluster I have in my house, so it's not like you do, but it's not it's just one cluster or one PC, so the other one's one. But yeah, it's just a quick little monitoring application, individual services, how much memory interface, blah, blah, blah. And it's got Embari also has a really good API. So I used to have, at Data Realty, I actually built a monitoring application for, because we had 12 physical clusters and a couple virtual clusters. It was a giant mess, but since I was using Embari for all those clusters, I'm actually able to build a monitoring application to monitor all the actual clusters and just be able to pull this from each one and go through it and just build a quick little heat map so you can tell what was going on and who received the data and stuff like that. So it's transferring data over the internet to make sure things stayed up to date, because people like to randomly move our little boxes and would send data. So, tell us like, oh no, just put it on a different network. Yeah, you have to reconfigure it so it'll actually send. Anyways, that's Embari. It's pretty easy, but it comes with Ganglia. It comes with all that already installed. This little paradigm. There's actually some more stuff that you can go into when you set it up. But just go Embari, and it's really easy. Like literally, all you have to do is add their repo on CentOS in there. Just download it. It's a couple commands. No Yeah.
Maybe, and if anyone else is more familiar, maybe I'm. Those you always ask that question. You feel like the only one, but I'm not familiar with some of those things. Like, I know I've seen Nagios before, but what are some of those things on the side there?
Sorry. Nagios and Ganglia, they're like service monitoring softwares. Basically every display you'll ever see like in a data center or someplace like that, or network managing tools, stuff like that, they're all based on Nagios and Ganglia. Ganglia is more services, Nagios is actually like PCs and stuff like that. That's where you get like all the time and stuff like that from. Where's it goes? So like from Ganglia you get like the CPU usage and stuff like that, disk usage and everything, and then like the actual uptime is handled by Ganglia. But Yarn, Yarn, basically how Hadoop 1 used to work was a little more rigid when it came to everything, and when they upgraded to Hadoop 2, they added what's called Yarn. So instead of having everything sit directly on top of it, basically Yarn's like the intermediary layer across the HDFS. So you can have not just, there's other tools that are kind of similar to Hadoop, like Spark, and I never used them, but I've seen them all. So basically you could have like all the other tools sitting on top of Yarn and use the same resource. So you can have one big cluster and be able to use multiple things. It's just like a switching or an API, or I guess would be considered for everything else. So you can just have multiple software things and be able to share the actual hardware resources with. Hive, Hive, we'll get into it a little bit later. It's a interface, SQL interface for Hadoop. So because like how Hadoop originally was designed, you basically make little Java applets or jar files or whatever to do anything, and which can be great out of, the only time I actually ever used the actual Java file was receipt data that we were getting in. So like literally it was like a binary text file of like receipts, just one after the other, after the other, after the other. So it's like, it's not organized, you can't pull data out of it really easily, so we actually have to use the Java. Learn how to program Java, and then learn how to write an application in Java real quick to grab that with the dude to be able to pluck it out where it was at and stuff. But Hive just sets it up for SQL queries. Makes it a hell of a lot easier. But you have to do tables, like there's two kinds of tables, which there's two kinds of tables in Hive. There's external and internal Hive tables. So like when you get when it sits on HDFS, because everything sits on HDFS, right? It's just a virtual file system. That's all it is. So it's root, whatever, it goes up. So like when you go to like /user/hive, and then there's like very else blah blah blah. Like if it's internal, Hive takes care of all the file management in there. If it's external, then you can give it file locations. So what we would usually do is, since we were pulling files from like all kinds of different sources and shoving them together, we would create external tables. So like basically that just points a table, like a Hive table looks at a directory. So it just goes, anything that's in this directory, any files that are in there is part of this Hive table. It works fine as long as everything's the same format. Obviously when it's not, then things have problems. But it's really handy for these, we would rsync things back and forth, so we just have it looking at these files, and it would update those files, and would update the table whenever we're trying to look at it. So it's very handy if you do the external tables, but it can cause little quirks for some of the software that like Scoop doesn't work really well with it, which Pig is just another way of thing like Hive. I never use it. Hive's just way easier. It's another language that you have to learn. Scoop is handy, but not with external tables. Is handy for pulling data in, so like out of like SQL databases and Oracle databases and stuff like that. So it's like a quick little dirty like command line like SQL, or not command SQL, but like a bash prompt command that you can run that'll pull like entire databases down and dump it into Hive. So it's really handy for that, but like it doesn't play well with external tables. So trust me, I tried on that a lot. Uzi and Zookeeper, yeah, it's got a little, not correct. And of course it's not gonna, I don't have that board up on the firewall, but Uzi is a scheduling. Because Hadoop is a batch drop system for running jobs and stuff like that, so you can only run like one job at a time. It was just a way to schedule it. So like if you're leaving at 5 and there's a job running currently, you can just schedule it. You think, oh, this job will only be done at midnight, or you know it would be done by midnight. You just set the job to start at midnight. That's all. This is nice and handy. And stuff like that. And I'm completely forgetting this does, but that's all I'm saying. You never really have to actually interface with it. It's just there. It's one of those things you always set up, but you never actually mess with.
Question. What was Hive again? Sorry.
Hive's the SQL interface.
Oh, okay.
So here. Oops. So this is actually on my server at home. So I can just Hive. Now, one of the downsides to do is there's always going to be an overhead on whatever you do. So usually like a 30-second overhead on whatever you run, but it gets after that 30-second overhead, it's a hell of a lot faster than you do. Like I actually had a client that made earlier. There was it was like 300 pages or something like that. It just text in and of the SQL interface, but they hadn't upgraded the hardware in like 10 years. So like literally to print the inventory for them would take a week. At least this is what they tell me. I didn't actually run the job itself. So about 10 minutes. Huh? 10 minutes. 15. Wow. Cluster. So and this wasn't like the greatest Hadoop cluster in the world. It was like the typical where we started from the Hadoop cluster wise were Dell C8000s. I don't know if you guys have ever heard of them. Probably not. They're like blade servers, but the only thing that shares in the lag backplane is power. So there's like everything else is still in the front for network wise, and so it just shares the power across the backplane. And so they're just like blade servers, but they come in like 5. We had the edge server, and then the name node, and then data nodes. Yeah, I'll get that. I'll get to the name node and data node in a minute. But anyways, when you're at Hive, you just do but yeah, it's just super commands.
So what, I guess maybe you'll go into it, but what would be a use case for using Hive or using Hadoop with Hive or whatever? Okay, I guess. You set up a Hadoop cluster and then you just like.
What I use it for was when you have crap tons of data, or when anything needs to be big, real big, like I would say, I mean, for the most part for us, we were pulling down, I mean, with all 12 of the clusters from the multiple clients, we were probably pulling down at least a petabyte of data a day, and that's just changes and pulling it down. So how MapReduce in itself actually works is all it's doing is taking, so kind of like this diagram here, it's taking a file and then you're giving it a command what you want to run. So say you want to do it with a simple join between 2 tables, right? For what if you use SQL for the most part. So adding up the student ID and year equals whatever you're comparing a student on it. Instead of just trying to run through on one job or one server and do that, what it does is it goes, oh, okay, well here's the 2 tables I need. It'll split it up into chunks, or however big you tell it what chunk it's going to be. I can't remember what the default is off the top of my head, but it'll split it up, and then it sends it out to all the data nodes, which are all the other servers in the cluster, and then they'll each process their chunk and then send the result back. So like, if you're trying to do a word count's the best way to do it this way. So like you have a big 300 gig text file, right? You want to tell it the word count, so like every time the pops up, or so like when you send it out to like 3 different data nodes or whatever this cluster, it'll say, oh, the showed up 10 times. Okay, node 2 will say the showed up 25 times. Node 3 will say the showed up 50 times or whatever. Then reducing it is just adding those together and going, okay, the showed up X how many times, right? Yeah.
So your like whole database is like spread across all these servers?
Yes.
Cluster?
Yeah, actually, this gives you an idea. It's also rack aware, which is really handy. So how it gets around redundancy and everything like that really help this way with So HDFS just looks like a normal Linux file system, right? What actually is having place here, so like in the diagram, you got 2 racks, right? Each server's got, there's 6 servers in each rack, right? Well, when you fill it in and let it know its rack location, right? It'll go, okay, well, we'll keep 2 copies of this file right next to each other. And then it'll go, oh, make sure if this rack goes, the whole rack goes down for some reason, we'll keep another file on the other rack. So that's the other thing you gotta keep aware of. It keeps 3 files of everything. Though you can change that if you want. Like I have mine set to 1 because I only have 1 PC, so it doesn't really matter if that one goes down. Because that's the whole idea is just that if a box goes down, you just pull it out, put a new one in it, and it'll sync everything back. So you don't have to worry about that, and then you can fix it later or someplace else. You don't have to worry about that. It's like as soon as it sees there's 2 copies of the file out there, it goes, okay, I need to put a 3rd on a server somewhere. So it'll know it's not reached too fast. Did I answer that right?
Yeah, I don't know anything, I'm just.
No, yeah.
I have a question about that. Can you use this with like virtual machines? Can you spread nodes across virtual machines?
Yes, I've done it with virtual machines, but it gets buggy as hell. Because it's the classic being virtual on top of virtual on top of virtual. You know, because you already got, yeah, there's already a couple in there, and it gets, you know, by the time you try to do like LVM, and then, you know, but then you add HDFS itself is virtual, and then that basically, at first we did virtual clusters for all the clients that wanted to be cheap, and it worked fine for probably like 6 months, and then like all kinds of wacky stuff started happening.
So it takes a pretty specific kind of configuration for this to perform enough to use kind of, like, I mean, you kind of have to design the hardware though.
Like before, like if I had a rash of power supplies go out a little while ago, like I had P4s and stuff, like the old Penny 4s, like you can just put junk servers, whatever, like it doesn't matter. As long as it's one CentOS or a version, you can do it on Ubuntu or whatever, I just use CentOS. They said it's got nice security features for these reasons. And if it can run Linux, pretty much any distro, or at least one of the major ones, it can run into a Hadoop cluster. I mean, I'm sure you can do it all Raspberry Pis if you wanted to. I mean, I'm sure there's probably some other issues in there trying to do something like that, because I know it will. But if it'll run CentOS, it'll probably run it just fine.
Are there clients or like slave software for non-Linux machines? Like could you put it on a phone or something? Like run out of the web browser? It's like I don't know.
There might be, I mean, well, the actual software stuff, like, the actual cluster-wise, it's just like no GUI, like, you know, stuff like that. I mean, it's pretty much all the same.
Yeah, same slave or whatever, how easy it was. How many people use that one?
Yeah, usually how we would do it was, makes it easier. We just have, because you have the name node right. I know I can't probably see that. You'd have the name node right, and then there's a secondary name node. And these are like the controllers, right? So these are what keep track of where all the file locations. Nothing's actually stored on here file-wise, but so nothing's actually stored on here, but like an index basically of where everything's at. And then you have whatever, how many data nodes, right? Like in the diagram there. And so this just is, what we would usually do is we'd have an edge node for every cluster. This was more of a security device than anything like that. So like this would be on its own subnet, right? And nothing can talk to it except through the edge node box. And so, like basically, we would have this pull from wherever we need to, like the name nodes would put out WebHCat and WebHDFS are APIs to access files, or WebHCat to access Hive databases and stuff, tables, all this, just little web APIs and stuff. So basically, you can run it all through here, so you can do all your security on here, and then whatever user wanted would come and access everything on the edge. This would have to do mix. One on that subnet, the public or whatever subnet for what the client would be. Is like now unless you have like an actual like Kerberos box, like we used to use for security clusters, where we had an IPA server. Unless you have that set up to actually do like Kerberos between all the clients and data and stuff, it's unsecure, really unsecure. So it's one of the reasons why we keep it off in some separate thing where it couldn't talk to anybody and stuff. And it's like it's only authentication is user. So I mean, it's like literally doesn't even look for password. And like, yeah. So but because it's taught, it has no way to like authenticate across by itself. That's authenticate between the machine besides SSH keys. You use passwordless authentication and stuff to go across. But I mean, there are different ways of being able to actually just give it the whatever. Oh yeah, actually this user. Oh okay. It doesn't care because it's not designed to be secure. It's designed to work. Okay. And but when you set it up with Kerberos and stuff like that, it's secure. Like it authenticates everything the IPA server before it does anything. So it works pretty well. Yeah. Did I go off on a tangent or did I answer your?
No, yeah. I guess what I was kind of getting is, and I don't know anything about this either, but could you set up like a botnet to be a Hadoop cluster or something? Like, you know what I mean? Like, I don't know.
I don't know. I mean, probably could. I'm guessing theoretically you probably could. I don't know if you could do it on phones per se. I mean, it would probably have to do some tweaking with the actual equipment itself to get it to run that way. But
I guess the question is how easy is it to install the slates on
Mm-hmm.
right?
Yeah.
I mean, when I first started doing this, and I first started doing like what do you call it, actual like base, like Apache Hadoop install, it was kind of a pain to like get everything set up. It's a whole lot of XML files and get everybody talking to each other and stuff on one port. So it's just like a whole bunch of ports you have to have open to get everybody to communicate, right? I wouldn't say it's impossible. I would say it's unlikely without somebody having some serious skills.
Okay.
But anything Linux based, you should probably come out now. So I mean, Mac or I've heard of people getting to run Mac clusters, but I don't know why you want to. But
I didn't mean to serious, right?
No,
I'm just
no.
curious.
I run off of yeah. So like, this is one a different idea for stuff that runs live for. There's all kinds of search.
Should you maximize that?
No, I'm sorry.
Thanks.
Yeah, like HBase is like a MongoDB-ish, like like database kind of on top of HBase. I never really used it much, but it works. Spark and Tez are like real-time processing ways. Like Tez kind of works with Hive. I didn't dig into it too much though. It's kind of weird, but because I know you can run Hive stuff with Tez. Like I ran some commands that way, but I never noticed the difference. So I mean, it's supposed to be some real-time processing stuff. Impala is Hive. It's just Cloudera's version of it. It's just named differently. Yeah, it's hard. Oh, yeah, Storm's like streaming stuff. I got that to work right. But, yeah, you get the idea. So it's supposed to sit on top of Yarn now instead of sitting directly in HTTPS, which makes it. Yeah, HCatalog and Web HCat is the web version, the API version of that. It's kind of the same thing as Hive, but it's like it's kind of the under thing of Hive. Means it's kind of SQL-y, but it can hold other things, other stuff besides Hive. But I've always just used Hive. But yeah, it has kind of like a SQL-esque query language. Like it's all documented pretty well, so you can do live drive. You can just look at the notes. For the most part, like that stuff. And like I said, pig is, it's another separate language that they made up that I never got around to it. Alright, I'll show you. So this was Ambari, and then this is just what I threw together over the last couple of weeks of, well, I guess it's been months now, but much time. I can get. So this is a web interface that I made. The entire thing is, it just goes off of WebHCat, WebHDFS. Oh yeah, it's that status thing. It's just a pink status thing I never got around. But so this is a Node.js application with an Angular front end, and literally all it's doing is hitting those APIs. It's just making curl less pretty much. And just yeah, I just have two databases on there. The only weird problem with making requests this way, yeah, you see it's one of the multiple and stuff, but you can submit queries. And then the only problem with submitting queries this way is like,
I had a double T.
Double T there.
no, but,
Sorry, still, is it double T?
no.
The second T in test.
It looks like I misspelled it when I entered the database name
Oh, okay.
That's why I was just copying off there.
Oh, sorry, I didn't see that.
Oh,
Maybe either, I don't know, let's see. Let's see what happens. So it's actually getting ready to run the job right now. The only problem is when you should see a pop-up when it gets done, but when you submit the job, it's like that select statement and stuff, like it doesn't actually send any results back. There's easier to show you the code, I guess. All right, so when this sends out, it gives you this job ID, right? And for the job, it just makes it a job ID for it, and you listen for it to it, right? But it just the only thing that you can do for it is give it like for that, but it'll just send back. It'll be okay. That's it. So it doesn't send the info back, so that you have to go fetch the actual file itself. But the problem is when you do it that way, like where it puts the results are kind of wonky. So like, I hadn't fixed this part yet, but basically the only way to actually tell it to like drop the results someplace that so you know where it's going to be at instead of having to search for it and stuff because I never remember where they put it. You can tell it like on HDFS what directory to dump the results, but that fix the actual way to actually do that yet. It's not fun. And not enough time. Blake's been out of town all week, so yeah, so we actually want to look at HDFS, like my kind of broke HDFS browser. It doesn't work at the moment. All you have to do is just to do FS, so when you're on the bash command line, and then dash whatever command you run, so dash ls slash for there or whatever, or cat, when you cat a file, or dash cat, yeah. So it's, so for like this is like do fs dash ls slash, it would be, if you wanted to cat a file, it would just be dash cat slash whatever. But it should be, anyways, it comes back and dumps down the directory. It's just a file that results of whatever you do. It's just a plain text file. I'm sure you guys will see plain text files. The only other thing with Hive is by default it handles CSVs, and it'll handle that fine. So I found it definitely to be the easiest just to get rid of CSVs before you upload it or do anything with it. It just makes life a lot easier. But you can make what are called inserters for it, serializers, deserializers, but they can be finicky to say anything like, because I made one for JSON, just to put JSON data in and stuff. Worked great for like 3 months and then stopped working. And it wasn't very helpful on explaining why it stopped working. I don't know. So I just started putting it with the CSV after that. So usually when you have a nice format like CS or JSON or whatever, it's pretty easy to put in CSV. So anybody else have any questions? I'm sure I missed some stuff. So. You look like you got a question there.
Me?
Yeah, you look like you're gonna ask one.
Do you know, like, I saw the Zookeeper. Do you know if this goes with like Apache Mesos at all? Or do you know about that? Or
Yes, I looked at Mesos.
I mean, would this be
Mesos kind of
online, or is it just something they both share?
Oh yeah, like Zookeepers using a lot of different things. I just don't remember what it does. At the moment, it's one of those things that's used in like everything, and then.
Okay.
But I never actually use it. It's used by software a lot. Yeah, it's used across a couple different things. Like and Mesos I was actually looking into using originally until Yarn came out, which does basically the same thing. Mesos is a little different, and there's like kind of like it's kind of weird. There's just like a company around it, so it's like
Oh, really?
yeah, it's a little. It's open source, but like at the same time, it's kind of trying to sell a distro at the same time, and like I don't know, it's a little weird. But that's kind of why I get away from it. It's just like, oh, they already put out Yarn that does the same thing, so why do I need these? Yeah. And Ambari took it up, and that just makes everything so much easier to install. Yeah, like screenshots for installing it, but literally it's just next to the installer. Yes, and it's installed. Just testing one. Yeah. Oh yeah, and then once you get the web interface up, then you just it just has then you just type in what posts you want to go to, get the SSH key, and you're good to go. It's really simple, good. It's really cool. All right then. No other questions or anything?
I guess I still feel a little confused.
Yeah.
It seems like it does a lot of different things, or like it kind of encompasses a lot of different like related things. So it's got the distributed file system, right? And then it seems like it's got lots of different things that are kind of built on top of that.
Yeah.
So if you want to do some distributed processing with it, then is that just done through the queries that you're submitting to it?
Oh, it is. Basically, when you submit those SQL queries, it's writing the MapReduce job, which is that really long, annoying Java job and stuff.
Okay.
It writes, basically, it's writing that for you, or pulling it out of a list of jars. Okay, this matches up, and then it shoots it off.
Oh, okay, so that's Hive, right?
That's Hive, yes.
Okay, so Hive is then like kind of being convenient for you to make queries to get data out by creating the MapReduce stuff for you.
Exactly.
But otherwise, you would be maybe writing some Java program that does the MapReduce to do some more complex kind of processing or something that would do anything you want, right?
Yeah, exactly. It's basically with Hive, you're just like they call it making tables and making databases and stuff like that. It's like you're not really doing that. You're just organizing the data so when you can just create SQL queries instead of having to write Java programs.
It almost looks like what, and I'm not very adept at all of this, but it looks similar to like what you do when you're doing something in business objects where you're writing a SQL query and hitting up against your data, only doing it more directly.
Oh yeah, and like
That's what it looks like.
Yeah, like that's kind of why the original way that when I originally started creating this web interface when I still worked for everybody and I had all that code and stuff there, like basically was more or less to give, because my boss didn't know how to command line into anything, so to give him a web query so we can SQL commands.
Right.
And that's basically what this started as and kind of went from there. So literally just being able to submit commands and then checking the goods and stuff.
Yeah, and that's open source way of doing it instead of having to go.
Yeah, these are,
Saturday can build a universe around it and all that stuff.
there is one way to do this. There's what's called U. It's a user environment. It's made put out there or much of them set up. But it's a real pain in the ass to set up. It uses the JDBC driver, which is put out by Mapbar, and they change the location of it on the website because they suck. So it's not fun trying to get that working. Like I think I've worked it up like 2 or 3 times. I think like at 10 or so attempts. Like it's like installing it and stuff, and it's fine. It's just like getting the drivers all working